All right, let's start it up. Just make sure, flip your page over right now. You got a big sheet of graph paper on top of the second page, right? Good. All right, on that sheet of graph paper right now, can you make me a 3x4 rectangle? So let's make the 3 going down, 1, 2, 3, and the 4 going across. 1, 2, 3, 4. Okay, 3x4. And then you got to flip back and forth, but can you find me the perimeter of that rectangle and the area? What's the perimeter of that rectangle and the area? We'll start there. All right, numbers are going to be useless today because it's going to be, nobody. Oh, nobody. Maybe I'll hit somebody sooner or later. So just, what's your perimeter here? 6 and 8, 14. Perimeter's 14. And how about the area? Length times width? 12. Okay, no issues there. And can you do me a favor so we keep track? Put like an ORIG in there so we know that's the original rectangle that we made, original rectangle. All right, we're going to make a second rectangle now, but here's my rule. It's got to be similar to this one. So let's talk. What makes the two rectangles similar? Their sides are in the same ratio. Okay, both sides are in the same ratio. So does anybody want to hook me up with another rectangle that would be similar in the same ratio as 3 to 4? 6 and 8. Yep, that's the common one. So here we go. Let's make a 6x8 rectangle now. 6 going down, 8 across. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Again, it's similar because it's in the same. If you do 6 over 8, that's the same ratio as 3 over 4. And same thing for me. Can you find the perimeter of this one and the area? Can you find the perimeter and the area of this one? Area 48. And how about the perimeter? Perimeter should have been 28. That's interesting, huh? We doubled the sides. The perimeter doubled, right? Did the area double? Oh, that's interesting. We need more, though. We need more. All right, let's make sure we put a 1, Roman numeral 1 in there. So that's rectangle 1. All right, anybody, let's do another rectangle that's similar. Anybody got measurements for a third one? Let's not get out of control here either, but 9 and 12. Okay, you got it. 9 and 12. 1, 2, 3, 4, 5, 6, 7. And you can put a 2 in there as well. This is rectangle 2. So quickly, just figure out the perimeter and area. What'd you get for the perimeter? Perimeter? What do we have? 42. So wait a sec. We just tripled the size and the perimeter tripled. What'd you get for the area? 108. Did the area triple? 12 to 108? No, it didn't. All right. One more. Anybody want to go smaller? Or you want to keep getting bigger?
1 by 2.
That wouldn't be in the same ratio though, right? 1 by 2, 3 to 4, 2 different ratios.
1.5 by 2.
Can we make 1.5 by 2? Is that all right? Go a little smaller, 1.5 by 2. Just do your best. 1.5 over 2. If you want to stick a 3 in there, go right ahead. Rectangle 3. What do you notice about the perimeter? What is it this time?
Half.
Well, what is it?
Half.
It's 7, right? Which was half. Perfect. It was half my original, yeah. And what about the area, though? What was the area? 3, right? Not half of 12. It should have been. I would have predicted 6, but it ended up being 3. So we're starting to see a little pattern here. The perimeter follows the rules, but the area doesn't. So if I double my sides, the perimeter doubles. If I triple my sides, so do the perimeter, but the area doesn't follow that rule. It follows another rule, which we're going to find right now. So go back to the first page here and help me fill in this chart right now. Let's compare the original rectangle to rectangle 1, which I have up on the board still. First thing I want is, what's the similarity ratio? Let's remind ourselves what a similarity ratio is again. The ratio of 2 corresponding sides. So 3 to 6, 4 to 8, they all reduce down to what?
1/2.
Okay, so the similarity, I'm sorry, I'm going to go other way because it's a similarity ratio of 1 to the original. So 6 to 3, 8 to 4, that reduces down to what? 2 over 1. Yep. Okay, can you guys look at the chart now? Look at the chart. What was the ratio of their perimeters now? Look at number 1. Look at rectangle 1's perimeter to the original's perimeter. 28 over 14. 28 over 14 reduces down to 2 over 1. Now do it for the areas. What was the area for rectangle 1? 48 over the original 12. That's not 2 to 1. That's 4 to 1. Yes. That was 4 to 1. All right, now compare 2 to the original. 2 to the original. So 9 to 3, 12 to 4. What's your similarity ratio?
3 to 1.
3 to 1. Look at your table now. Look at the perimeters. 2 to original. 42 to 14. Does that reduce? 3 to 1 again. 108 to 12.
9.
Ooh. Anybody see maybe a pattern here yet?
This.
Oh, maybe you do, maybe you don't. We still got one more. Last one. 3 to the original. So 2 to 4. What's that reduced down to? 1 over 1 to 2. Look at the perimeter. The perimeter of 3 was 7. The perimeter of the original was 14. 7 over 14. 1 over 2. And then how about the areas? 3 over 12. Oh, 1 over 4. All right, let's see if we found anything here. Okay, let's see if we found anything. How do the ratio of the perimeters and the ratio of the areas compare to the similarity ratio? All right, here you go. Help me fill in the blanks here. Whatever the similarity ratio is, that's the same as the what? If I know the similarity ratio, I'll also know the
Ratio perimeters.
perimeter ratio. Agreed? Okay, so let me put this in symbolic form that you'll start seeing me right, because I don't want to have to write this every time. S1 over S2, that's your similarity ratio. Figure 1 to figure 2 is the same as P1 over P2. Any guesses what P stands for? Perimeter ratios, correct. Those are always the same. Ooh, you ready? Different story for area though, right? Here you go, here you go. Let's see if anybody can figure this one out. If I know the similarity ratio, I'm going to write something that's incorrect right now, and you tell me how to fix it. That is not a true statement. You got look at your darn chart. 1/2 to 1/4, 3 to 1, 9 to 1. They're not ever equal to each other. I need to adjust this somehow so they are equal. Zach, what do I need to do?
The area ratio is similar to the square root, not square root, similar ratio squared.
Okay, I need to take my similarity ratio and yes. No, not double it. Because if you look, you double, let's see, where is it? You double 3, you get 6, not 9. Right? You square it. All right? You square the similarity ratio to get to the area ratio. So if we're putting this into some symbols, S1 over S2, show me you're squaring each of those numbers now, and you'll get the area. So yes, perimeter and similarity always equal, but you got to square the similarity to get to the area. Anything before we start applying this? Hopefully, if it doesn't make sense now, once we start doing a couple problems, it'll be all right. All right, let's see what you got. I'm telling you they're similar. These two figures are similar. Can you find me what the perimeter ratio is and the area ratio? Well, before I do that, though, don't I need the similarity ratio? Right? Can you guys start out with the similarity ratio here? I'll just put it up here near it. What S1 over S2 would be here. And don't make it complicated. That's just the ratio of two sides that match up. I only gave you two sides that match up, right? So what's my similarity ratio here?
4 to 5.
4 to 5. Yeah, don't make it complicated. 4 to 5. There's your similarity ratio. Okay, automatically then, what's your perimeter ratio? Also, 4 to 5. And before I move on to area, I want to make something clear here so we understand. Am I saying that the perimeter of the first one is 4 and the perimeter of the second one is 2? No. Here's what I'm saying. Whatever the perimeters are, you put them over each other, and guess what they're reducing down to? 4 to 5. That's what this is not telling you what the perimeters are, actually. Just tells you what ratio they're in. All right. How about their areas? 4 to 5 too? 4 to 5? No. What do I need to do to 4 to 5 to get to the area ratio? Square them, yes. So the area ratio, 16 over. It doesn't mean 116 and 125. That does not. It might be, but it's in some ratio of 16 to 25. Guys all good?
Yeah.
All right, a little bit, not much, but a little bit tougher on 2. Finding the similarity ratio here. I know it's going to be 3 to something. You guys got to figure out what the 3 would match up with. So again, if you can visualize, put the congruent angles on top of each other and see where 3 would fall on top of. Because it's either 8 or 5 it's going to fall on top of. So try to visually put those congruent angles and right on, smack on top of each other. Where's the 3 going to match up with? Where you got, Via?
So the similarity ratio is 3 to 5.
3 to 5, correct.
Okay.
Anybody want a sneaky way of getting that? Everyone see how 3's across from this angle with 2 arcs? What's across from this angle with 2 arcs? 5. It's a little sneaky way in case you can't visualize it. All right, then what's the perimeter ratio?
3 to 5.
3 to 5 again. Again, not saying it's actually 3 and actually 5. It's just in some ratio of 3 to 5. And area ratio not equal to 3 to 5,
9 to 25.
but 3 squared over 5 squared. 9 over 25. Oh, we're picking this up before I throw a little wrinkle in. Go backwards. That's what I'm going to do with 3. You got 2 hexagons that have an area. Area! area of 8 and 32. What's the similarity ratio? So now take a look. Now I'm giving you A1 over A2 is 8 and 32. I need your help to get to S1 over S2. So I'm going, see how I'm going backwards now? Going backwards. Well, how do I get from S1, S2 to A1, A2? What do I do there? I square them. I square them to get there. So what do you think I do in algebra days to go backwards if something's squared? Take the square root. Correct. Take the square root. All right, so everyone hop on your calculators right now. Square root of 8 over square root of 32. Should come out to be a nice fraction for you. Nice fraction. What is it? 1/2. Yep. Anybody need a little help getting that on the calc? All good? What's up, Romeo?
Does it matter if you do the whole thing, whole square, like under the whole square root? Or?
This is the same as if you did a big square root. They both mean the same. Good question. Yep. They both mean the same. Yep. And 2 circles now. I'm going to give you the areas here. 128 pi over 18 pi. Again, how do I go backwards? For S1, S2, take square root. And your calculator can handle this. If you want to put it under 1 square root, like I just talked to Romeo about, feel free. And hopefully a nice number again. No decimals, right? What is this one here? 8 and 3? Is it? And just because, again, you guys are above average class, what figures were we talking about here? Circles? Isn't S1 over S2 the ratio of 2 sides? So how does that fit into circles then? Because circles don't have sides. But what do they have that we could measure? Yeah, the radii, right? The radii are a ratio of 8 to 3, or their diameters, or their chords. Okay, so that's, I know circles don't have sides, so what the heck does that mean? Yeah, their radii are in a ratio of 8 to 3. All good? All right, this last problem is just basically, do we know what the heck has been going on today? Because this is where I need you to be. 2 rectangles similar to each other. Shorter side of one is 6 feet. Shorter side of another, I should probably switch those. 6 feet, 9 feet. Area of the smaller one is 48 square feet. What is the area of the bigger one? Okay, let's see how far we have come today. What's the similarity ratio? 6 over 9. Area of the smaller one is 48. What's the area of the bigger one? Hopefully you're not solving that. Hopefully you got a problem with what I wrote up there. If you're going to solve that, you're telling me this is true. Right? 6 over 9. Same as the areas. If you're going to cross multiply right now and solve that, that's what you're telling me. Is that true? Absolutely not. How do I adjust it to make it true? Square. I guess we could square, but that's going to be chaos. Square the 6 and the 9. Yes. Do not set the similarity and area ever equal to each other. You're better than that. And then what's the area of the bigger one?
144.
144.
Wait, no.
I don't have 144. 81 times 48
Oh, I actually.
divided by 36, 108 square feet. All right. Do not set similarity equal to area. What's your deal? You all right? You good? All right. Anybody else? That was fun. It's nice when it's a nice smaller group, huh? Half the class now to finish the homework. Here you go.